Standard string theory suffers from a persistent structural flaw: its absolute reliance on spatial compactifications, specifically Calabi-Yau manifolds, to hide extra dimensions. As seen in this abstract representation, these geometric manifolds are inherently unstable, prone to topological collapse. By forcing 10 or 11 dimensions into a purely geometric framework, physicists inherit an unmanageably complex landscape of moduli spaces. The direct consequence of this moduli complexity is that vacuum states are left dynamically vulnerable to tachyonic decay. There is an alternative approach. We can achieve absolute string closure by relying strictly on algebraic structures, bypassing the need for physical geometry entirely. This mathematical alternative is the Raccoon Unified Algebraic Framework. We are replacing Calabi-Yau moduli with pure algebraic closure. This diagram illustrates the mechanism. The framework maps exceptional Lie algebras from the Freudenthal-Rosenfeld-Tits magic square directly into a rigid 24-dimensional lattice, labeled here as lambda 24, without requiring artificial glue codes. By executing this mapping, the 24-dimensional lattice provides a strict, mathematically rigid proof of string theory closure, completely independent of extra spatial dimensions. The first step in this proof requires constructing an even, unimodular lattice without defaulting to the standard auxiliary Galais glue codes used in historical models. We begin with a 248 by 248 matrix grid. The highlighted 20 by 20 core, the E8 and F4 algebras, falls short of rank 24 conformal anomaly cancellation. Appending 4 orthogonal quaternionic vectors, x245 through x248, yields 224 null vectors, leaving only the pristine 24 by 24 core visible. Taking the determinant of this newly formed 24 basis submatrix yields a value of exactly 1. A determinant of exactly 1 proves the lattice is unimodular. The initial geometry is now perfectly locked into place. With the lattice established, we most satisfy the strict requirement of Lie bracket closure across the new 24-dimensional space. This Lie bracket equation demonstrates that the structure constants, the Fijk terms, must resolve strictly within the 248 dimensions to prevent the generation of anomalous outside terms. We execute the full tensor contraction over the matrix generators to test this boundary. The Lie bracket equation translates directly into the Jacobi identity, which systematically cancels out to equal exactly 0 for all possible algebraic combinations. This perfect zero-sum cancellation dictates the central charge of the entire framework. Locking the central charge at exactly c equals 24 proves geometric closure. The system permits zero energy leaks into non-physical dimensions. Standard string theory vacuums destabilize because they permit norm 2 roots. In physics, these highly unstable roots manifest as destructive tachyons. The Raccoon semi-composition algebra inherently possesses a set of polynomial constraints designed to govern valid quantum states. We evaluate these specific constraints mathematically by applying Grobner basis calculations. This data grid isolates the result. The minimal norm eigenvalue for the weight 1 vertex operators evaluates to exactly 4. Because the absolute lowest eigenvalue is 4, vectors of length 2 cannot mathematically exist within this space. We define this resulting mathematical structure as strictly Leach-like, characterized specifically by the total absence of these lower norm roots. By mathematically forbidding norm 2 roots, tachyonic vacuum decay is rendered algebraically impossible across all vertex operator weights. We must also address the genus 27 moduli space, a complex geometric landscape shown here, where unconstrained vacua typically degenerate into instability. To stabilize this chaotic space, we introduce the degree 6 Raccoon invariant, denoted mathematically as script I. We apply this invariant by solving the spectral polynomial of the 56-dimensional Lax matrix, overlaid here on the genus 27 spectral curve. The output of this Lax matrix polynomial yields exactly 5 distinct unique numerical roots: -9, -6, -3, -2.5, and 0. Because these 5 specific roots are non-degenerate, they successfully and globally separate the topological orbits. This strict orbit separation enables the script I invariant to uniquely identify the correct stable vacuum state among the degenerate possibilities. This unique algebraic identification provides rigid stabilization of the vacuum. It requires no arbitrary geometric forcing to remain intact. The final objective of this proof requires calculating the partition function, z of tau, for the vertex operator algebra over this newly stabilized space. Because the space is strictly rootless, there are no norm 2 states to disrupt the Hilbert space. This rootless condition strictly forces the SL2Z modular transformation to behave in a constrained manner. As this animation demonstrates, the transformation cleanly resolves to match the expansion of the holomorphic J invariant. We then calculate the weight 2 dimension counts, derived explicitly from the bilinears of the 248 algebraic generators. The final numerical result of this expansion yields exactly 196,884 independent dimensions. Reaching exactly 196,884 dimensions mathematically proves that the algebra has closed perfectly on the Grease algebra of the monster group. This flowchart summarizes the complete architectural derivation we have established over 5 mathematical steps. Integrating the E8, F4, E6, and E7 sectors with quaternonial phases inherently satisfies all required Leech lattice properties within a unified 24-dimensional manifold. This specific rootless construction mathematically guarantees a strictly positive mass gap in the resulting physical equations. Compared to traditional models, this pure algebraic rigidity achieves everything string phenomenologists attempt to engineer through geometric compactification. The strict norm constraints eliminate tachyons entirely from the spectrum. Furthermore, the degree 6 invariant permanently stabilizes the monster symmetric vacuum. String theory closure is proven algebraically. The requirement for Calabi-Yau spatial compactification is eliminated.